Okay. So, yeah, so yesterday we were seeing methods of separation. In the last class, we were seeing methods of separation. Okay. So, what are the methods of separation do we know by now? We have discussed all of them except chromatography. Only the chromatography was left. Okay, so what are the methods of separation? Whatever you remember, just quickly if you can just tell me.
Hand picking.
Very good.
What's it called? Disintegration.
What?
Disintegration. No, filterization.
See, again and again, I'm telling you, try to pronounce it right. Okay, because if you'll pronounce it right, you will spell it right. Okay, so it's not filterization, it's filtration. Okay, say it with me. It's filtration.
Filtration.
Okay, it's filtration, not filterization. You are making mistakes again and again. Okay, so when you will write it, you will write the same wrong spelling that you have been speaking. Okay, so just try to pronounce the words correctly. So, okay, very good. Filtration. Then, what else?
Um.
You don't know. Okay, I think everything has like evaporated from the top of your head. Okay, during this weekend, yes or no? So we'll do one thing. We'll just quickly revise it. Okay, we'll just quickly revise the rest of the methods of separation that we have already done, and then we will move on to chromatography. Okay, is it okay?
Okay.
Yeah.
Yeah.
So I'll share the screen.
Methods of separation. Substances can be separated into. You need to mute.
Yeah, I'm muting myself. Okay, we'll just quickly see all these processes. Okay, and then we will go to chromatography, right?
Yeah. To their components by various methods like hand picking, winnowing, sedimentation, decantation, sieving, filtration, etc. Each component of a mixture has its own unique property. Based on this property, components can be separated. Hand picking. Oh my god, I didn't know your sister.
I'm sorry, I can't talk.
Involves manual picking. Hand picking
I'm gonna go write in my journal. Wait! This method is adopted based on the size, shape, and color of the solid components in a mixture. Example: stones, pulses, small pieces of other grains can be removed.
Okay, so if I ask you, what is the principle for hand picking? Okay, what is this process based on? What you will tell? Can you use hand picking for all the mixtures? Can we use hand picking to separate all the mixtures? No. Okay, why can't we use? Suppose I give you salt and sugar mixture. Okay, I give you salt and sugar mixture. Okay, how will you separate salt and sugar mixture with hand picking? Will you be able to? Tell me yes or no. No, right? Why? Because the size, okay, there is the size difference between the salt particles and sugar particles is very less. Okay, it is approximately of the same size, right? And then the color is also same. It is both white. Okay, so it will be very difficult for you to distinguish which particles are actually of salt and which are of sugar, right? So you cannot use hand picking for separating salt and sugar mixture. Okay, so if I ask you what is the principle this hand picking method is based on, you will tell that it is based on three things. Okay, we saw in the video also. First, it is based on the size of the particles, right? It is based on the size of the particles. Second, we have the color of the particles as well, right? We have color of the particles. See, suppose if you just take the best example for hand picking is what our mothers used to do in kitchen. Okay, I don't think you would be having these you would have seen this before, but we in our childhood we used to see our mothers doing the same thing. Okay, now also, however good quality grain you buy, okay, be it wheat, rice, anything, however good quality grain you buy, there must be some stones present in the grains. Okay, so before actually cooking the rice, what we have to do, we have to just hand pick the stones. Okay, why? Because stones will obviously will be bigger in size than the rice grains, plus the color of the stones will be, it will be either black, brown, red. Okay, and the color of the rice is white, so it will be very visible to us. Okay, it will be very easy for us to differentiate between the stone and the rice grains. Okay, are we clear about this? Okay. So, hand picking, okay, whenever you will be asked what is the principle, the most like basic question from these methods of separation is principles. Okay, what principles are they based on? Okay, so you have to remember the principles at least. Okay, so hand picking, we are done with hand picking. You won't forget it again. Okay.
From rice grains by hand picking method. Winnowing. Winnowing is used to separate heavier and lighter components of a mixture by wind or by blowing air. Example, winnowing is mainly used to separate husk from paddy grains. The mixture is thrown up in the air by one person using a plate-like device. The grains used to separate husk. Here, light particles like husk are blown away and heavier particles like paddy grains are left out. Winnowing machines are used for winnowing in rice mills. Sedimentation, decantation, and filtration. The process of settling down heavier insoluble solid components in a solution is called as sedimentation. The component of mixture which settles down is called as sediment, and the clear liquid is called as supernatant. Example, when muddy water is allowed to stand for some time, mud and sand particles settle down as sediments. The clear water is obtained as a supernatant. The process of transferring the clear liquid without disturbing the sediment is called as decantation. Example, the supernatant is slowly poured into a beaker without disturbing the mud settled as a sediment by the process of decantation. But decantation cannot separate the components of a mixture completely. The method of separating an insoluble suspended component of a solution using a filter is called as filtration. In this process, the solution which is decanted is allowed to pass through perforated membrane called as filter. The filters can vary with their pore sizes, which allow only liquid particles to pass through them. The suspended particles which cannot pass through the filter paper are left behind in the paper. Filter paper acts as a strainer. A filter can be filter paper, muslin cloth, cotton layer, layer of sand, etc. The clear liquid collected after filtration is called as filtering. The suspended component left behind in the filter is called as the residue. Example: fruit juices are filtered to separate the seeds and pulp particles using a muslin cloth. Sewing and
Okay, so after hand picking, we have a process known as winnowing. Okay, and in winnowing also we have like types. Okay, sedimentation, decantation, and filtration are just types of winnowing only. Okay, not exactly filtration. Filtration is a separate thing, but this sedimentation and decantation process, it will usually follow with filtration. Okay, so yeah, so what is winnowing? If I ask you what is the principle of winnowing, what it is based on, what you will tell?
the wind
Okay, the wind, then
and getting rid of it's
husk,
called a
husk of the
husk.
grains, right? Okay, but yeah, so how does it actually works? The heavier particle, okay, the what is a heavier particle? If I just give you some harvest, okay, I'll just give you some paddy harvest, okay, rice, okay. So the we have seen the husk also, right? The husk, I have shared the screen with you in one of the classes. Yes or no? We have seen the
Yes.
structure of the rice grain, right? Okay, so inside, outside of the rice grain there is a husk. Okay, there is some brown colored substance that is known as the husk that will cover the rice grain. Okay, so this husk will be lighter and the grains will be heavier. So what will happen? The person, it used to like before it was used to be done like this. Now we have winnowing mills and all, we have machines. But before, what the farmers used to do, they will stand on an elevated platform. Okay, they'll stand on an elevated platform and they will just start throwing the grains. Okay, they will stand opposite to the direction of the wind. Okay, so what will happen, sorry, in the direction of the wind. Okay, so what will happen? With the wind current, the husk being lighter, it will be blown off, where as the grains it will fall down. Okay, then they can collect the rice grains and they can go home, right? So this is how the farmers used to practice this winnowing. Okay, so what is the principle? It requires a substance with a mixture with a lighter component and a heavier component. Okay, so the heavier component in this case is the rice grain, whereas the lighter component is the husk. Okay, now the same, using the same principle, we have something known as a sedimentation process. Okay, what is the sedimentation process? The heavier particles will settle down. Okay, the heavier particles of the mixture will settle down. Okay, suppose I give you the example that I have been giving from the starting of this chapter. I give you a glass. Okay, I'll glass of water and I'll add tablespoons of sand in it. Okay, and I'll mix it. Okay, I'll ask you to separate it. How will you separate the sand and water? How will you separate? You will allow the,
Boil it.
no, you cannot boil it. See, why boiling is used? Boiling is used to kill the microorganisms. Okay, these microorganisms you won't even be able to see with your naked eyes. Okay, we don't have. Just try to do it in your home. Just take a glass. Okay, mix it with some soil and just boil it. Do you think the sand will go? Where will the sand go?
It will go into the air.
You can say one thing that no, the sand won't go into the air. How will the sand go into the air? See, you can say one thing, that the water, upon constant boiling, the water will evaporate and you will be getting the sand behind. Okay, this is one method that you can do, that we have to evaporate the water and then we can get the sand. Okay, but in sedimentation, see, but we are losing water over here, right? In this process of evaporation, we are losing water, we are just getting one component here. Okay, but using sedimentation, we are having both the sand, okay, and the water will also be there at the end of the process. Okay, so sedimentation can also be done. Okay, so for sedimentation, what you can do, you can just take the glass and let it rest for 2 to 3 hours. Okay, so what will happen? All the sand particles being heavier than the water molecules, they will just settle down at the bottom of the glass. Okay, that we have seen in the video. Okay, then what you can do, just you can carefully, you can just the upper layer will be water, so you can just remove the upper layer of water into a different vessel. Okay, so this process is known as decantation. Okay, without disturbing the sedimented particles, we are just taking away the water. Okay, so this particular process is known as decantation, right? After decantation, still after decantation, even after sedimentation and decantation, there will be some particles of soil that will still be in the water, okay, that you can easily see with your eyes. Okay, you'll be able to see with your eyes, right? So to remove those particles of sand or soil from the water, what we have to do, we have to do filtration. Okay, so this filter paper, they will have pores in it. Okay, and the pore size of different filter papers depends. Okay, or if you want to like if you want to separate a particle that is really really small, so a really small pore size will be available. Okay, so depending upon the size of the particles, the pore size of the filter paper should also be considered. Okay, so suppose we are having sand over here, so what we will do, we will just pour the decanted water that we have already placed it in a different vessel, we'll just pour it into the filter paper. Okay, so all the soil particles that are still present in the water, it will be just absorbed by the filter paper, it will be embedded in the pores of the filter paper. Okay, now if I ask you, can you drink this water now after filtration? Yes or no? Tell me, will you be able to drink this water now?
No.
No. Why? Because their microorganisms are also present, right? You cannot see them, but they are present. Okay, we have just mixed 2 tablespoons of soil in it. Okay, there are so many microorganisms in soil, harmful microorganisms, right? So we have to remove that also before drinking. So what you can do, we can boil the water and then we can use for drinking purposes. Okay, so this is exactly,
Wouldn't you want cold water to drink?
yeah.
Wouldn't you want cold water to drink? It would be hot water.
Okay, you can just let it after boiling it. Okay, the after boiling it, the microorganisms will be killed. Okay, so you can just take it, bottle it up in a freezer, keep it, and then you can drink the water. Okay, is it okay? Okay, so I think we are done with hand picking, we are done with winnowing, we are done with sedimentation and decantation and also filtration. Okay, but filtration is not exactly a part of this winnowing. Okay, filtration is dependent upon, is depends upon this different principle. Okay, what is the principle of filtration? Tell me,
Huh?
what is the principle of filtration?
Filtration.
It depends upon the size of the particles, right? The smaller size particles will be filtrated, okay, using a filter paper. It just depends upon the size of the components of the mixture. Okay, so according to the components, you can just use a different sized filter papers. Are we clear about filtration also? Shall we move ahead? Yes or no, Naveen?
Yeah.
Okay.
And filtration. It is the separation method used to separate solid components of a solid mixture. It is based on the difference of particle size of the components in a mixture. Sieving is done by using a small device called a sieve. A sieve has small holes of uniform size. Smaller particles pass through the holes of a sieve and bigger particles are retained in the sieve. The sieves differ with their sizes of holes. Example, a big slanting sieve is used to remove pieces of stones, husk from the wheat. A small round sieve is used to separate impurities from the flour. Sometimes, pearls of different sizes are separated by sieving. Distillation is the process which involves the separation of two miscible liquids that boil without decomposition.
mixture of alcohol and water. They are completely miscible. Alcohol boils at 78.5 degrees Celsius and water boils at 100 degrees Celsius. Mixture is taken in a distillation flask and a thermometer is fixed. Heat the mixture to more than 80 degrees Celsius. Alcohol vaporizes and condenses in the condenser, which can be collected from the condenser outlet. Water is left behind in the condensation flask.
Activity: why can't we filter salt from salt water? Take a beaker with some water and add some salt in that water. What do we observe now? We observe that salt dissolves in water completely. Now, take a filter and try to separate the salt from the salt water. We can't separate the salt from that water. It is because the size of salt particles that are dissolved in water are smaller than the pores in a filter paper. So, we cannot see them with naked eye. Hence, the dissolved salt particles cannot be filtered from salt water. Activity: crystallization. Crystallization is a separation process. Let us know this separation process by performing an activity. Take a beaker with salt water and keep it over a flame. Now, stir the solution with a glass rod. Heat the solution till the total water in the beaker gets evaporated. Finally, we find that salt crystals and powder left in the beaker. Thus, the salt crystals are separated from salt water. This process is known as crystallization. Generally, water gets evaporated in presence of sunlight. This property is used for extracting salt from seawater. Seawater is captured in wide pans and exposed to air and sunlight. Then, water gets evaporated and salt remains in the pans.
Sublimation.
All right. So there is this evaporation process. It can also be used as a method of separation, right? We generally use this method of separation for separating salt from seawater. Okay. So what we will have big lagoons. Okay, we will have big lagoons. Okay, they are just pits. They are shallow pits. Okay. So the seawater will be filled in these lagoons, and they will be kept under sunlight, okay, for 4 to 5 days. So after 4 to 5 days, what will happen? All this water will be evaporated and the salt will be left behind. Okay, so this salt then can be processed and then can be used for um, selling it. Okay, so this is basically this process of evaporation is basically used for separating salt from seawater. Okay, now we will see sublimation. Can you remember what sublimation is? We have already discussed it. Tell me. You forgot. Sublimation. See, what will happen if I heat ice? Tell me what will happen if I heat ice? Yeah, it will turn into water. And now what will happen if I heat water? If I start boiling it, what will happen? It will turn into gas. Yes or no? Yeah, okay. But there are some substances, okay, they will directly convert from solid to gas and gas to solid. Okay, there will not be any intermediate step in between. They won't be converting into liquid. Okay, directly from solid to gas and gas to solid. Okay, there won't be any liquid state in the middle. Okay, so the process of conversion of solid into gas directly without converting into liquid is known as sublimation. Okay, so last time I gave you examples, right, for naphthalene balls. Okay, these naphthalene balls, camphor, okay, all these are products that can undergo sublimation. Okay, what are naphthalene balls used for? Tell me, I told yesterday. Hmm? What are naphthalene balls used for? Naphthalene balls are generally used to keep the moths away or the insects away from clothes. Okay, so they are generally used in cupboards, right? And in washrooms also, you would have seen they use naphthalene balls. Okay, so we will see sublimation now. How sublimation can actually be used as a method of separation, we will see it now. Okay.
Okay.
The substances, that is solids, which convert themselves into gas without forming liquids, are called as sublimable substances. Phenomenon is called as sublimation. Take a mixture of ammonium chloride and salt in a watch glass. Cover the watch glass with a glass funnel. Heat the mixture. Ammonium chloride is sublimed as pure vapors. These vapors settle down on the sides of the flask, and salt is left out in the watch glass.
Activity: sublimation of camphor. Take a mixture of camphor and powdered salt in a china dish and cover that dish with a funnel. Close the tube of the funnel with cotton. Place the dish on a stand and heat it with a burner. After some time, you can observe that the camphor converts to gaseous state without forming any liquid state. Similarly, on cooling, the gaseous form of camphor changes directly into a solid form without going to any liquid form. The process in which a substance changes directly from solid to gaseous form and vice versa is called sublimation.
Chromatography, a novel method of separation. Let us perform an activity. Let us take
Okay, so I think sublimation is clear. Yes or no? Do you want me to explain it, or we can just go directly to chromatography? Naveen?
Yes, clear.
Yeah, it's clear, right? Okay. So, but this sublimation can only be used for products that actually go under sublimation, right? We cannot use it for something else. Okay. So that we have to keep in mind. Okay. Now we will see chromatography. Okay, this chromatography is also a very like easy technique which you can see it. You can do it in your home also. First, we will see it here in this video, and then I have one more video for chromatography. Okay, so what you can chromatography are actually different. There are different types of chromatography. Okay, so chromatography the one we can do in home is paper chromatography actually. Okay, so it's very easy, you can do it. I'll just show you the continue with the video, just a moment.
a rectangular sheet of filter paper of approximately 10 centimeters to 8 centimeters. Draw a pencil line at about 2 centimeters to mark the baseline. Mix blue and red inks in equal proportions. this ink. Let it dry. Insert this filter paper into a jar containing water just as to touch the water level. Leave it. Water rises up on the filter paper. Two different spots are obtained. Two separate solutes present in a solution are identified. The colored component soluble in water rises up quickly. This is the phenomenon of chromatography. It is the technique used to separate the solutes dissolved in the same solvent.
Activity: a chalk with different.
Okay, so you what you can do is you can just take a filter paper. Okay, just take a filter paper and just put a dot. Okay, just put a dot of an ink. Okay, you can just use a marker for that purpose, right? You don't need separating. This marker also will just make a dot. Okay, with marker, and just put that paper into water. Okay, so that the water should be touching that dot. Okay, after some time what you will see, you will be seeing different colors. Okay, different colors, the colors that are actually used in making the ink of that marker. Okay, marker, I think it has green color, red color, blue, black. Okay, so you'll be able to see all those colors in the filter paper. Okay, I have one more video. Okay, you will see that it is actually the just the paper chromatography that will be seeing in that video. Okay, the one I explained you right now. Okay, just a moment.
In today's video, we're going to talk about paper chromatography. We'll take a look at how it's done, explain the theory behind it, like what the mobile and stationary phases mean, and also show you how to calculate RF values. Now, chromatography is a general analytical technique used to separate the different substances in a mixture so that we can then identify them. And there are actually lots of different types of chromatography. But the one you need to know about is paper chromatography, which can be used to separate the different dyes in an ink. The first step is to take a piece of filter paper and use a pencil to draw a line near the bottom of the sheet, which we call our baseline. Next, you want to add your sample of ink, which you think might contain lots of different substances, to the pencil line. Then we need to find a beaker and fill it with a shallow amount of solvent, like water or ethanol. We are now ready to start, and we can place the filter paper into the solvent. But importantly, we have to make sure that we don't submerge our pencil line and our spot of ink, which is why we made our solvent shallow. And if you're being careful, you should really place a lid on top to stop the solvent from evaporating. And we just wait for the solvent to seep up the paper, and as it does so, the different dyes that make up our ink will dissolve in the solvent and move up with it. What makes this interesting, though, is that each of the different dyes will travel up the paper at different rates, and so they'll end up separating out, which tells us that each one must be a different substance. So we've basically separated out the different substances.
So any ink that we are using is not just made up of one color. Okay, if I just give you a marker, a black marker, in that black marker there will be many different dyes that are actually used to make that combination of color that we see it as black. Okay, so it's not like if I am just giving you a black marker, it will have only black ink in it. Okay, you will see only black dye in it. No, there are different colors of dyes that are actually mixed to give you that color of ink. Okay, so basically this chromatography is used to separate the dyes from this ink. Okay, so suppose I'm giving you a black marker, so in that black marker there might be green color, red color, blue color. Okay, upon mixing these three colors we are getting black color. Okay, so we can separate these dyes from that black colored ink. Okay, so that is what paper chromatography is. Okay, rest of the things you don't have to know now. Okay, you'll be learning it in higher grades, right? So this is what paper chromatography is. Okay. Okay, so I think we are done with all the methods of separation. Okay, there's just one more activity left that you can see. Okay, this one also we used to do it in our homes, right? You can also try doing it. Okay, I'll just share the screen.
Different colors. Take a whole stick of white chalk and put a blue ink mark around the curved surface of the chalk. Now, take some water in a plate and keep the chalk in the water. Take care that the water in the plate does not touch the ink. Observe the color patterns on chalk after some time. Chalk can absorb the water, thus, we find changes in the ink mark on the chalk. Now, remove the chalk from the plate before the water reaches to the top. You can find different colors on the chalk from top to bottom. These colors have formed from only a single ink. The ink appears as a single color, but it is actually a mixture of many colors that are hidden in it. This process is an example for chromatography technique. We use this technique to separate components from a liquid mixture. We know that a leaf appears green in color, but if we use the chromatography technique for that leaf, then we can find that a leaf consists of a number of colors.
Okay, so this was about chromatography, right? So we have. Are you clear with this chromatography method as well? Yes or no, Naveen? Okay, okay, so we are done with this methods of separation. Okay, we are done with this methods of separation. Okay, so I think this will be quite helpful for you, right? Because it is like in higher grades as well, you'll be reading the same thing again and again. I think till high school you'll be reading the same thing just in a more detail. Okay, just in a little bit more detail. So I think this the basics for this should be strong. That is why I gave so much time to this particular topic. Okay, so we are done with methods of separation. Okay, so we were originally doing the chapter materials of daily use, right? From materials of daily use, this is just a topic of that chapter, this separation methods. Okay, it may not have been like given in this detail in that chapter, but I still took it because it's just a very important chapter, right? Okay, so yeah, so materials of daily use, we saw clothes, right? We saw clothes we are using daily. We saw different fabrics that. Hello. Hello.